Well, folks, today we're going to talk about how big atoms are.
All right.
You know, atoms have different sizes.
Yeah, they're not all the same. Every element has a different size.
So you're saying size matters,
It
Mr.
does.
Sams.
In terms of these elements, it definitely matters.
It does matter. Okay, so in the atomic size, think of atoms having different sizes. So sodium is bigger than, say, argon.
Mm-hmm.
And so in silicon. So just think of different sized spheres. And so that's atomic radius. It's just the radius of an atom. The radius, of course, is, you know, from algebra and geometry, I guess it would be. A radius is the distance from the center of the sphere. Don't think of these as circles, but as spheres. Now, as we understand the atomic radii, one thing we should talk about. Mr. Sands, you want to talk about this right here?
We can't really measure the radius of an atom because there's really no outside edge of an atom. You know, it's where the outside of the atom is where the electrons are 90% of the time.
Right.
That's really how we get the size. But what you can do is if you take two atoms, I should say, of the same element, you can measure the distance between the nuclei of those two atoms and then just cut that in half, and voila, you have the radius.
Right. Okay. Now, let's talk. It turns out we're learning about something called periodic trends. A periodic trend is something that happens periodically on the periodic table. And so if you look down a column, and so here, for example, is the first column on the periodic table. Yeah. Lithium, sodium, potassium, rubidium. And these numbers are their sizes, 152 picometers up to 270 picometers. Right. A picometer is a very small unit. It's a trillionth of a meter.
Yeah, so what we're looking at here is as we go down a period, we're adding energy levels. So lithium is in the 2s, the outside electrons are in the 2s. Sodium is in the 3s, potassium 4s, rubidium 5s, and so on. So as we get higher energy levels, as we've talked about before, those electrons on average are getting further and further and further away from the nucleus. So as we add energy levels, we get further away from the nucleus, we get a larger radius.
That is correct. Perfect. Okay. So as you go down a column, and so here is actually the trend, the atomic radii trend. So as you go, you might want to sketch this or possibly print this. Yeah. And so as you go across a period, the biggest element in each part of the periodic table are these alkali metals. Yeah. And so let's
talk about the left-right trend here.
Yeah, so let's talk about, the across a period. Remember, on the periodic table, across is called a period, and down is called a column. So as you go across the period, they get smaller. Now, that's weird, because if I'm looking
across meaning from left to right.
Yes, that is correct. So if I look at sodium has a mass of 23. Calcium or magnesium is 24. Aluminum is 27. And you go all the way across, and argon 40. Is like 40. So they get heavier. So as you go across, they get heavier.
But they get smaller.
That's
weird.
Okay, that's what happens. Let's learn about that. So let's kind of look at the periodic table here. Right. So let's pretend this is the periodic table right here. Here I've got my periodic table right here. Okay. And so the biggest atom on the periodic table is right here, which is francium. So he was the largest of all the atoms. And the smallest atom is helium. Okay? Mm-hmm. And so as you go across, they get smaller. And as you go down, they get larger. All right?
Okay.
So remember to understand that.
Do we need to talk about why they get smaller as we go across?
That's our next slide, Mr. Sams. So as you go across a period, they get smaller. This is the one that's weird. Why is it that they get smaller? Yeah. So if you go from potassium, which is row 4, and you go down, they generally get smaller. How come? Well, it's because you're adding two things. As you go across a period, you are also adding an additional proton in the nucleus of the atom. Right. So if you take, for example, potassium, who weighs 40, right? 39 maybe?
39, yeah.
39. And then the next element is calcium, which weighs 40. What you're doing is you're adding one additional proton. So this one has 20 protons, and he has 19 protons. So as you have this has a charge of plus 20. This is the calcium. And then I'll draw it over here. Here this has a charge of plus 19. This is the potassium. This is the calcium. So as you add this additional proton, it's holding on to the same electron shell. Mm-hmm. So it's going to...
So both of those are holding on to the 4s shell.
And so this one will be a smaller shell.
Because there's a larger positive charge pulling that negatively charged shell into it.
Think of it like it's like a stronger magnet. It's one more proton makes this magnet stronger than this, and that causes it to shrink. And so as you go across, it just shrinks a little bit and a little bit because you keep adding a proton. Now, when you get to the end of a row, and then you jump up to say rubidium right here, it jumps way up. Guess what? You now have a whole nother shell out here to hold on to, and that's why it gets bigger.
All right.
The last thing to talk about in this podcast, real short podcast, is ionic radius. Now, ionic radius is the radius of an ion. And an ion, of course, is something with a charge.
It's a charge, yeah.
The general rule is if it has a positive charge, like lithium ion, Li positive, it has lost an electron. Remember, it's kind of weird. Positive ions lose electrons. Negative ions, so actually let me finish. Lithium then is smaller. So Li positive is smaller than Li because he has one less electron.
Right, lost an electron. So now it has 3 protons in the nucleus and only 2 electrons if it loses one of them. So those 3 protons can pull in those 2 electrons stronger than if there were 3 electrons because there's a greater positive charge in the nucleus.
And of course, when you go to beryllium, he's lost 2 electrons, and so you keep losing electrons.
Right.
Now, the opposite happens when you look at, see, the huge things are these ions. So if you take, say, chloride, that means he's got, chloride has 17 protons, and he's got 18 electrons. So he can't hold on to those electrons as well, so therefore chloride is much bigger than chlorine.
Right. I like to use the babysitter and kid analogy here.
Oh,
so
yeah.
You've got, if you look at lithium, you've got 3 protons. We're going to call those the babysitters. And the kids are the electrons running around. If you've got 3 babysitters and 2 kids, those babysitters are going to be able to keep a pretty close eye on the kids. They're going to be able to hold them in nice and tight. Okay. However, if you look at chloride, if you look in the nucleus, there's 17 protons, 17 babysitters, and 18 electrons, 18 kids. The kids outnumber the babysitters, which means there's always going to be one kid running out further out of somebody's reach, and they're going to be able to spread out further than if the babysitters outnumber the kids.
Yep.
So if the babysitters outnumber the kids, pulls it in smaller. If the kids outnumber the babysitters, stretches out bigger.
That's right. Okay. So we should do just an example, Mr.
Okay.
Sims. So which one's bigger, chromium or bromine?
Let's take a look at a
Yeah, I got to look
table
at the periodic table. So chromium is right here, and bromine is right here. So we're going across a period.
From left to right, and they get smaller as we go to the right.
All right. So the bigger one would be the chromium. So chromium is the larger one, right?
Yep.
All right, let's look at oxygen and selenium. So oxygen is here, element 8, selenium, element 34. So we're going, as you go down a period, they get larger.
So selenium is bigger.
Selenium wins. And then platinum and sulfur. Platinum is here, and sulfur is here. Now, that's kind of a weird one.
Yeah.
Because as you go across, they get smaller. As you go down, they get larger. Well, actually,
so we're going to the right, it gets smaller, and up they also get smaller, so sulfur is obviously smaller.
So platinum is our bigger one.
Yeah.
So, hey, we should do one more, Mr. Sams.
Okay.
We should do like some ions. So calcium or calcium ion, Mr. Sams. Now, calcium symbol is Ca. Calcium ion is Ca plus 2.
Right, so the plus 2 means it lost 2 electrons, so it lost 2 kids, if you will. So which means the babysitters outnumber the kids, so it's going to pull those in, so the calcium ion is smaller.
So the calcium is bigger. I'm circling the big ones.
Okay.
Nitrogen or nitride. That's N versus N negative 3.
All right, negative 3 means it gained 3 electrons, which means you gained 3 kids, meaning the kids outnumber the babysitters, so the nitride is bigger than the nitrogen.
That's correct.
Alrighty.
Folks, that's the podcast. We'll see you. Bye.
Bye.